A bit of history. We find in Aristotle the idea of equality of action and reaction, but it is rather a psychological aspect. It was not until the 6th century, with John Philippon, that the conservation of momentum appeared, a driving principle which he called impetus. Man transmits a driving principle to the bow. The bow transmits this driving principle to the arrow. The principle of conservation of impetus was taken up by John Buridan in the 14th century and by Nicolas Decaux a century later. Galileo had the intuition of inertia, and the laws of the movement of bodies, but it fell to Descartes to formulate them. Descartes' vision is conditioned by the fact that only a direct action by contact of one body on another can physically exist. Descartes' second rule will be the foundation of fluid mechanics and mainly of the kinetic theory of gases. Everything was going to change with Newton. Although he did not really believe in the possibility of remote attraction, his system of gravitation involved no contact between bodies. So he invented a new law, replacing Descartes' second rule. This was his famous third law: action is always equal to reaction. That is to say that the actions of two bodies on each other are always equal and in opposite directions. Leibniz generalized this law: once there is a being B on which another being A acts, and two there is a reaction consisting of an action of B on A. Leibniz thus introduces a difference in nature between action and reaction. Of course, mathematically, there is no difference between the two. But in reality, these are two separate phenomena. This is what Diderot will express in his own way. I see everything in action and in reaction, everything destroying itself in a form, everything being recomposed under another. Kant will attempt to generalize Newton's law to the field of law. Newton's first law is identical to Descartes' first rule and concerns an isolated body. Every body perseveres in the state of rest, or of uniform motion in a straight line in which it finds itself, unless some force acts on it, and forces it to change its state. The second rule of Descartes expresses an equality of exchange in a dynamic framework. This rule was removed by Newton and replaced by his third law of equality of action and reaction. Newton's third law does not involve motion. In reality, Newton's mechanics did not need conservation of momentum, Descartes' second rule. This rule is of no use for astronomy calculations. The bodies of the cosmos can only exceptionally collide. Newton's third law expresses the equality of action and reaction. However, this affirmation is immediately rectified by the rest of the text. Newton stipulates that it is a question of the reciprocal actions of one body on another. The actions of two bodies on each other are always equal and in opposite directions. The reactions are gone. Thanks to this sleight of hand, Newton allows his law of gravitation to appear to respect the principle of equality of action and reaction. Newton's third law relates to two actions. Although he used the word reaction, Newton explicitly expresses that it is in fact two reciprocal and equal actions. Moreover, Newton applies his third law to the gravitational action of a body A on a body B equal and opposite to the gravitational action of a body A on a body B. In reality, the true principle of equality of action and reaction concerns the equality of an action and the reaction it provokes. The reaction has no reason to be of the same nature as the action, even if it is expressed mathematically by the same arrow symbols. The example of the magnet and the piece of iron helps to understand the problem. If the piece of iron is fixed in some way, the magnet will move closer to the iron. From the mathematical point of view, everything is perfect. The action of the iron on the magnet is identical to the action of the magnet on the iron. However, the action of iron on the magnet has no relation to the action of the magnet on iron. Only the magnet has a magnetic field acting on the iron. Iron attracts nothing at all. Iron is passive. The generating fact of the movement is located exclusively in the magnet. Before a beam is laid, its two supports are unconstrained. As soon as the beam is placed, the supports are each subjected to an action, a force, equal to half the weight of the beam, but the reactions of the supports are constraints that have no physical relationship with the weight of the beam, even if there is equality of action and reaction. The reactions of the supports are reflected in the ground under the piles of the bridge. The ground reacts to the weight of the beam with pressure. At the same time, the ends of the beam are stressed due to the reaction of the supports. The reaction of the supports to the weight of the beam is at the same time an action on the ends of the beam. In this example, there are two action-reaction pairs. On the one hand, the weight of the beam, and the reaction of the ground by pressure, and on the other hand the constraints in the supports and at the ends of the beam. Only these two constraints are physically of the same nature. Their similarity and equality seem to prove Newton right. However, they would not exist without the first couple action of the weight of the beam and reaction of the pressure of the ground. Let us now place a body A in the gravitational field of a body B. Body B exerts a gravitational force on body A, and body A exerts a gravitational force on body B. These are indeed two distinct and equal actions, as we know. But where is the reaction of body B to the action of body A? Where is the reaction of body A to the action of body B? The gravitation of body B is in no way generated by body A. It exists even if body B is not in the presence of body A. And the reverse is true for the gravitation of body A whose body B has been approached. Where are the reactions? Newton was suspicious. He did write that the reaction is equal to the action, but to specify immediately that it is a question of two equal reciprocal actions. He had a mathematician's vision. In his equations, there is nothing to distinguish an action from a reaction. The equality of action and reaction is a physicist's problem. Newton is not concerned. To tell the truth, you will think that I am really interested in a detail here. However, there is another detail. When we admire the sky, we are struck by the circular movement of the cosmos. Everything revolves in the cosmos. The cosmos is therefore the seat of angular moments. However, Newton's gravitation, like Einstein's general relativity, does not make the slightest allusion to this abundance of rotations of the stars on themselves, to these angular moments. The Earth, like all the planets and the Sun of course, rotate on their own. The Moon always shows the same face, towards the Earth, but it also turns on itself during the lunar month while revolving around the Earth. These angular moments compensate each other, of course, but how? Neither Newton's gravitation nor Einstein's general relativity provides the slightest element of the answer. What if Descartes was right? Descartes has an answer for angular moments. The problem is that his solution for gravitation doesn't work. Something is missing in his ether.